Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. 2010 paper 2, this was a question on probability. Two events A and B are such that the probability of A is equal to 0.2. The probability of A intersection B is 0.15, and the probability of not A intersection B is 0.6. Complete the Venn diagram. Okay, so I can see my intersection is in there in the middle. Probability of A is the whole circle A. Okay, so if 0.15 of it is here and it all adds up to 0.2, that means that there's only 0.05 left for just A alone, okay? And now that adds up to the 0.2 that's there. Okay, the probability of not A intersecting with B, okay? So not A means I not A, so I'm deleting out, I'm trying to visually delete out A, okay? So not A, where does it intersect with B? Well, that's 0.6, okay? So that only leaves that area there. And I don't subtract off the 0.15 because you can see that when I do not A, that area, that intersection disappears. So that's not including 0.15. Okay, so let's add that up. So we have the 0.2 there in A plus the 0.6 in B, which is 0.8. So out here on the outside, I have 0.2 because of course, all probability has to add up to 1. Find the probability that neither A nor B happens. Well, that's out here. If that's A happening and that's B happening, then out here is where none of it happened. Okay, find conditional probability, the probability of A given B has occurred. So one of the formulas that you need to know, it's the intersection over the second one. Okay, so check out the 2012 question again for more on this and to give yourself a chance to practice it again. So the probability of B is not 0.6, but it's 0.6 plus the 0.15. So it's actually 0.75. Okay, so if I put that into my calculator, 0.15 over 0.75, I get a fifth or 0.2. Okay, lots of 0.2s. Okay, state whether A and B are independent events. Okay, so 3 formulas for independent events. The probability of A given B is equal to the probability of just A, okay? And that's what independent events mean. The fact that B occurred has no bearing on the probability of A. And of course, the reverse is also true. The probability of B occurring given A has occurred is just B. And then the third one, the probability of A intersection B is probability of A by the probability of B. Okay, and it doesn't matter which one you take. That's an easy one there to take because we've just worked out the probability of A intersection or A given B. So the probability of A given B is 0.2. We're wondering, is that equal to the probability of A, which is 0.2? They are equal, so therefore events are independent. Okay, of course you could do it with any of them. You could work out the probability of B given A has occurred. So that would be the intersection over the probability of A and show that you get the same answer. And of course, the bottom one, the probability of A intersection B is 0.15 equal to 0.2 by 0.75, 0.2 by 0.75. is indeed equal to 0.15, okay? And there's the same conclusion. So any of them will show that they are independent events, and these are the 2 main formulas you need to know for verifying or proving things in probability. The third one you should know how to do is mutually exclusive events, okay? And just for completion, mutually exclusive events to show events that are mutually exclusive. And a mutually exclusive event is one that cannot happen at the same time. So therefore, A union B is the probability of A plus the probability of B. So we don't subtract off the intersection here because there is no intersection. Mutually exclusive events means the events cannot happen at the same time, which means if I was to draw a Venn diagram for mutually exclusive events, sorry, that's really bad. Okay. It would be, that's the probability of A, that's the probability of B, and there would be no overlap. Okay, so that's why A union B in that case is just probability of A plus the probability of B. That's how we prove events are mutually exclusive. So this formula here, probability, conditional probability, and independent events, very important that you know how to do all three. If you've enjoyed this video, then why not join us in IT Sligo and use maths in practice. In conjunction with industry, we've designed an exciting new program in electronics and self-driving technologies, which uses cutting-edge techniques such as artificial intelligence, computer vision, and virtual and augmented reality. You'll need a H5 in maths to qualify. Check out the link below.